Hello everybody. The topic for today's video will be the ambiguous case of the sine law. And I'm going to break this topic into two videos, so here is part one. Before I get into the ambiguous case, I want to review some ideas with you. So I've called this section triangle information because, well, I guess I'll maybe just show you. I think that would be a little bit easier. So what I'm referring to is this. You can see this triangle has this certain information in it. So my question to you is, if I wanted to find a missing side in this triangle, what would I do? What math property would I use to find it? So if you've been thinking about it, you'll likely come across, well, you could figure out this is 60 right here, and then you'd have a angle side pairing, so you should be able to use sine law. So I'll write sine down here. And I agree. Now, if we check out the type of information this triangle gives us, we would call this triangle an angle side angle triangle. So angle, side, angle. So whenever you have a triangle that gives you information like this, an angle, side, angle, triangle, we know we can use sine law. Now typically you don't really need to know the angle, side, angle part. You can just visually check out this triangle and determine you can use sine law, but it's going to be helpful when we're dealing with ambiguous case. Let's look at another one. Okay, for this second one here, sorry, you can see the writing disappeared on the left side, so I can really quickly just rewrite that. So we said that was sine law, and it was angle, side, angle. And I'll even do this, angle, side, angle. Okay, on this one, if I wanted to find a missing side length, again, this time I'm given my angle side pairing right away, so I know, again, it's sine law. And then what type of information do I have? Well, this one gives me an angle, another angle, and a side. So angle, angle, side. So in these two cases, when you have these types of triangles, and you have previously, so in the acute triangles section and in the obtuse triangles section where we're just dealing with sine law, all the triangles were looking like this, we know to use sine law. Let's keep moving. How about this situation? Well, in this situation, you can see I don't have an angle side pair, so automatically I would have to use law of cosines, or cosine law. What type of information does it have? Well, it has side, side, side. So whenever you're given just three sides, we know to use cosine law. Another situation, and again, sorry, my picture disappeared on me. Just the way I designed this presentation. Maybe it wasn't the best design, but I thought it would save me some time, so make a quicker video. Anyway, keep going here. Same deal in this triangle over here. If I was trying to find a side length or something, I can't use sine law, so automatically then I know I have to use cosine law. And what do I have here? Well, this would be side, angle, side. So when you have a triangle that gives you side, angle, side, you know to use law of cosines. Again, you don't need to have this side, 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 and side, angle, side items memorized. You can do it without that, but just with what I want to kind of show with ambiguous case, I'm bringing this idea up. So now, in this last section of this first area I'm reviewing with you, it says what's left? Well, if you think about it, one thing that might be left is an angle, angle, angle situation. So we've looked at all the other kind of situations except for this angle, angle, angle. Well, you won't have angle, angle, angle. That doesn't give us enough information to find things. Angle, angle, angle does do something, similarity and proportion, other ideas you'll talk about later. But for solving, we're never just going to have a triangle that gives us all three. So don't worry about that. Is there anything else? Well, there's one more, and again, sorry, angle, angle, angle. And it'd be this guy here. Now, if you look at it, if you had to find a missing side length, you might think, okay, well, that's not so bad. I see I have my angle side pair, so I know it's going to be sine law. And if I look at what type of information they're giving me, this would be angle side, side. Kind of spells a bad word. I'm going to put that backwards down here. SSA, I'll say, side, side, angle. This is what we want to look at in this video. When you have a situation with angle side side or side side angle, whichever way you want to say it, this is what is referred to as the ambiguous case. Now, why is it ambiguous? Well, ambiguous, again, all that means truly is, I'm just going to say, unclear. it's an unclear situation. We're not actually sure how to represent that triangle because based on this information, you might actually have 0 triangles possible, 1 triangle, or 2 triangles possible. Now, what does that mean? I'm going to show you that in a minute, but this is what we're focusing on, this side-side angle situation, which is also referred to as the ambiguous case. Okay, so let's explore this side-side angle situation. So the first thing I'm going to do is just let's highlight a triangle here. So this is going to be our general triangle we're working with. You can see I don't have actual specific numbers. And you can see that I have an angle here, a side, and a side. So this is my angle side, side. And these are the terms I'm going to use. Okay, so we're going to refer to this side that is right beside the angle as adjacent. And we're going to refer to this side as the opposite. So opposite is always through, adjacent is always beside. You would have used this terminology before with triangles most likely, so I don't think this is anything new. Now, because of the information in this triangle, so they gave us that angle side side, this information doesn't lock down these two angles. So because those angles aren't locked down, that means that this side length here, this opposite side, could be drawn in a different fashion. Like it could be drawn maybe this way too. It might be the same length, but it could go that way. So because they don't lock down those angles, that means that there's an opportunity to make different arrangements of this triangle, and that still makes sense. So let's just actually look at it, because I know talking about it might not make too much sense. So the first case, let's actually look at 0 triangles. When would there ever be 0 triangles? Okay, well, I'm going to draw my general triangle, or at least part of it. Okay. Again, this is my adjacent. And then this would be my opposite somewhere over here. So if we wanted to make just one triangle, well, how long would this opposite side have to be? So again, this opposite side over here. Well, if you wanted just one triangle, the shortest that side length could be would actually be this perpendicular distance from that baseline up to that top, which is also referred to as the height. So that is the shortest that your opposite side can be. Now, if that's the shortest, that means if the opposite side is shorter than the height, then automatically there will be no triangles possible. So it means they might give you the information, but it wouldn't be we're not physically able to actually build that triangle. So how would that look if I just draw it below here? So I would have something like this. There's my theta, this is my adjacent, this is my opposite. It just doesn't actually reach all the way down to that baseline. So 0 triangles will occur when the opposite side is smaller than the height. The height is a really important feature in side-side angle situations. We're going to need to find the height to make all these types of all these calls on how many triangles. So let's take a second and look at how to calculate this height. If we just focus back in right here for a second, you can see that I have a right triangle. And to find then the height here, I can use one of my SOHCAHTOA ratios, my primary ratios. And I want to use one that would use the opposite side and then the hypotenuse. So now they'd have new names. If I'm dealing with that right triangle, that would be the opposite side and the adjacent. So to find the height, we could just go sine theta equals the opposite would be the height, and then over the hypotenuse, which is actually the adjacent. I hope I'm not losing you on that. And then we want to isolate that height. So I'll just use cross multiplication. And this is how I would find the height. And we're going to work on examples in the next video about how to find the height and all that. So that'll make a bit more sense. But know for now that you need to find the height. And once you know the height, then you can compare it to the opposite side and maybe the adjacent side. And that's going to help us determine how many triangles. Okay, so before I go to the next slide, also remember, whenever your opposite side is less than the height, you're going to have 0 triangles. Okay, let's look at now then one triangle. Okay, one triangle can actually occur a couple different ways. So I'll say A. The first one we already looked at, when the opposite side is equal to your height. So again, I'll draw this. So that's my theta. This is my adjacent. We know this would be my height. Okay, right there. Trying to make my right angle. And the opposite side, which I'll draw in red, it's going to actually be equal to the height, the exact same size. So when the opposite side is equivalent to your height, then that's going to leave you with one triangle. The other way you can do it is if your opposite side is longer than the height and longer than the adjacent. So how would that look? Or I guess I could write that out first. So your opposite side is longer than the height, and the opposite side is larger than the adjacent. So how could that look? I'll make that one really long there. Opposite. There's my adjacent. Because I said I'd make this in red, didn't I? So let's go over this in red. That didn't go over perfectly, but whatever. And again, here's my height. So you can see that this opposite side is longer than my height, and it's longer than the adjacent. So the only triangle possible would be the one I've drawn. So there's only one triangle. This stuff is tough to show in static pictures that aren't moving. So if this isn't making sense, you might want to YouTube how they kind of come about, these triangles, because if I had a video of myself on the board, it'd be much easier to show you, but with what I'm using, it's kind of tough to show that. The third and final situation would be if there's two triangles possible. Sorry, lost my train of thought there for a second. Okay, and two triangles will occur if your opposite side is larger than your height, but then smaller, and then the opposite side, sorry, is smaller than the adjacent. Okay, so now how does that look? Well, I'll have to draw two triangles, right? I'll draw kind of one general one here first. So I'm just going to leave it like that. Theta, adjacent, opposite. So that one's not a completed side because I don't know how long to draw it. Remember, you have your height here. So that's my height. And then I'm just going to extend this line too. I'm going to make it dotted because we're not sure how long it's supposed to go. But if your opposite is a length that is larger than the height, so let's say that, it's larger than the height, and it's smaller than the adjacent, we can draw one here, and then I could actually swing it over. If it's like a pendulum and just swung it, and then it would actually also hit the line right there. So that would mean two possible triangles. So the first one would look like this. I guess I'll use green here again. That's the first one. The second one would look more like this. And that's how these triangles always look. And I like to call them, I like to name them according to this angle down here. Maybe I'll use red. Okay, and in this one, this is an acute angle. You can see it's less than 90. And in this one, it's an obtuse angle. It's greater than 90. And that's always what occurs. You're going to have one acute triangle and one obtuse triangle. So that is how, that is how many different triangles are possible. So again, what that really means is when you encounter these situations, you have to determine how many triangles are possible, because that will then tell you how many sets of answers you're going to need. So for this case over here where there's two triangles, that means this information is unclear and you think there's actually two ways you could draw the situation, meaning that there's two valid answers. And then you could present both answers to whoever was kind of wondering about the question or asking the question. And then they would like to say, oh, whoops, I didn't give you quite enough information. I meant this triangle here. So they would pick whatever answer kind of fits their situation. The side-side angle also exists in obtuse triangles. So if you look back there, those were always acute triangles I was drawing you. And then when there was two triangles, there is an obtuse that pops up. But in the previous ones, those were acute. So I don't know if I pointed that out, but that was acute. In this one here, this is obtuse. So this is my obtuse angle. Okay, again, previously those were acute. Acute is where all the work is. Obtuse is pretty straightforward. Obtuse goes like this. There's either a triangle or there isn't. So one possibility is that there's 0 triangles possible. What happens there? If I draw my kind of general situation like I have on the left here. So this is my angle, it's obtuse. This is my adjacent. The opposite side has to be longer than the adjacent in order for it to actually reach the baseline. So I'll just draw it there. I'm going to draw it a little bit short. But so if it's not if it's not long enough, and I will go like this and like this. If it's not long enough, it might only get to say there. And it's not obviously going to touch the base, or sorry, the bottom anymore. So it'd just be kind of a broken triangle. So if your opposite is shorter than your adjacent, and even if it's equal to your adjacent, it's not going to actually reach the baseline. So what I mean by if it's equal to, if I drew it straight over top, it's going to reach if it's straight over top, but then we only have 2 lines. So 2 lines aren't a triangle. You need 3 lines. As soon as you draw any type of angle on this, it's going to always, it'll come really close, but it would come up short. The second situation is there would be 1 triangle, and for that to occur, the opposite has to be larger than your adjacent. So again, here we go. There's my angle. So the opposite side has to be longer than that adjacent to actually make that happen. So the opposite is greater than the adjacent. Okay, so that was a lot of information. Like I said, it's tough to show with just static pictures like this. If I had a video of myself on the board, which I'll try to produce here one of these times, it'd be a lot easier. You can definitely check out YouTube, though. There's lots of great videos by great math teachers who have already shown this, so it's not like I really need to. Here's a quick summary for your notes. So the side-side angle summary for acute triangles. In acute angle side-side triangles, situations, the following triangles are possible. So again, in acute situations, so that's when it looks like this, everybody. And I kind of never draw the opposite the full way, but there's my angle. Here is adjacent, and this would be opposite over here. And again, the really important feature is we need to find the height. And once we find the height, the height, everybody, we already showed it once, but is equal to this. Sine of whatever angle you're given times the adjacent. But here are situations. So 0 triangles if the opposite side is less than the height. 1 triangle if the opposite side is equal to the height, or if the opposite side is greater than the adjacent side and height. I guess height and adjacent side. And then we have 2 triangles if the opposite side is larger than the height and the opposite side is less than the adjacent. And then here's your summary for the obtuse triangles. And again, how does that look? The general picture for that one is like this. And again, I won't draw that the full way because we don't know how long that side is, but here's my just kind of general setup. 0 triangles if the opposite side is less than the adjacent. 0 triangles if the opposite side is equal to the adjacent side. And then 1 triangle if the opposite side is larger than the adjacent. Okay, so there's all the thinking and background work with respect to this side-side angle, the ambiguous case. In the next video, we'll actually do examples and put all this into use, and hopefully that'll help you guys out. Okay, have a great night, everyone.